Okay, so if you remember LOTUS, which we did earlier, okay, there is also a two-dimensional LOTUS. Okay, so this is 2D LOTUS. So so suppose you want to figure out expected value of gxy, okay, where the input to g is two random variables. So since the input to g is two random variables, the output is also random variable. Okay, so we can figure out its expectation, and this is what it is: the expectation of gxy. It is just sum it over all possible values of x and y, gxy, into the joint PMF of x and y. Okay, that's it. Simple formula. Okay, and it makes sense, right? I mean, that's how you actually find expectation. Now because it depends on the two random variables, okay, so therefore you're going to do the double sum. Okay, now you could have also done it, as I've told you, the other way to do the same thing is first find the distribution of gxy and then find expected value of gxy. So that's another way to do it. But if you want to do it directly, this is also correct. This is known as two-dimensional LOTUS. Is that okay? And similarly, you can have three-dimensional, four-dimensional, or basically any number of arguments is acceptable. Okay. Now let me give you the definition of covariance. Covariance between x and y. Okay. So what is the covariance between the two random variables x and y? So I'll be using either this to denote it, or I'll be using this to denote it. Both are, if I use this or this, I mean, I'm just talking about covariance. Okay. Okay, so what is covariance of x and y? It is basically this thing. Okay, it's the expected value of x minus ex into y minus ey. Okay, and it's actually if you remember variance is actually a special case of covariance. I mean, you can actually think of variance of x as covariance of x and x. So if you take the covariance of x with itself, you get the variance of x. Is that fine? Okay, so what is the idea behind covariance? So covariance, um, actually, I mean, I would say the most important property of covariance is that whether it is negative or positive tells you, in some sense, what is the association between x and y. Are they positively associated with each other, or are they negatively associated with each other? Okay, so its sign tells you that. So if this term is positive, if this number is positive, then you say that x and y have positive association. If this number is negative, then we say it has negative association. Is that okay? So let me just quickly ask you this. Okay, suppose there are 10 students in the class. Okay, suppose for student 1, I know the pocket money that the student receives from the parent. Okay, and I also know how much this student spend out of his pocket money spending. Is that okay? I know the pocket money and I know this, and that is something that I know for all 10 students. Okay, I know their pocket money and I know their spending. Now suppose my experiment is the following. Experiment is randomly drawing a student, drawing one student from this class of 10 students. So this is my Okay, suppose I randomly draw one student from this class of 10 students. Can you tell me, suppose I define X as pocket money of the student that you have drawn. Okay, and Y is the total spending, how much money that student spends, okay, of the student drawn. How do you interpret expected value of X? What is expected value of X? Okay, let me give you some numbers. Okay, so let's say this is K. K is 1 to 10. Okay, 1 to 10. Okay, and let's say the pocket money is 10K. Okay, 10K doesn't mean 10,000. Okay, 10K means if the individual is 1, his pocket money is 10. If he's 2, his pocket money is 20. If he's 3, pocket money is 30, and so on and so forth. Can you tell me what is expected value of X? Remember that each student is equally likely to be drawn. What is the interpretation of expected value of X? What is this number expected value of X? Remember that every student is equally likely to be drawn. So how do you, what is it in this particular experiment where you're drawing a student randomly from the class of 10 students, where X is basically nothing but the pocket money of the student drawn? Can you tell me what is the expected value of X?
Average pocket money.
So what is the average pocket money? Ten plus 20 plus 30 plus 40 plus 50 plus 60 plus 70 plus 80 plus 90 plus 100 divided by 10, right? So which is what, 55? Yes or no?
It's 55.
Yes.
Okay, so expected value of X is 55. Now suppose every student is actually spending 80% of their pocket money. Okay, can you tell me what is the expected value of Y?
44.
80%.
Yeah, I think it is 44, right? Just check. I think so. Yeah, 44. Okay, is that clear? Okay, so this is 55 in this example, this is 44. Okay, now if I'll ask you what is the covariance between X and Y, just think about the sign of the covariance. What could be the sign of the covariance? It turns out that the sign of the covariance will be positive. The reason is because higher the pocket money, higher the spending on an average. Does this make sense? If your pocket money is 30, then you are spending 24. If your pocket money is 40, you are spending 32. If your pocket money is 100, you're spending 80. Okay, so I mean, it's this kind of upward relationship. Covariance gives you exactly that. Covariance tells you, if covariance, the sign of the covariance is positive, you will get you can infer that there is a positive association between X and Y. Okay, if the sign of the covariance is negative, then you can infer that there is a negative association between X and Y. Is that clear? Okay, so let's quickly figure out the covariance. Okay, now to figure out the covariance, okay, you can actually do that using the formula. I mean, it's not difficult. Once you have these numbers, you can easily figure out. Let me first give you an alternative way of finding covariance. Remember, for variance also there were two formulas. In exactly the same way, you can actually derive this formula for covariance by first taking their product and then using the linearity of expectation. You will get this. So I leave it as an exercise because I've already done the variance one. Why the second formula, the derivation for the second formula for the variance, the procedure is exactly the same. Okay, so if you just open this and then do the expectations, you will get this. That's a covariance. Is that fine?
Yes, Professor.
Is that okay? So now, I mean, if you want to figure out what is the expected value of xy, that's not difficult at all. I mean, you first create x times y. So what is x times y? X times y is 80k squared. Okay, x times y is 80k squared. Okay, and then use that, because k goes from 1 to 10, so you can easily figure out the expected value of xy by doing this summation 80k square, k equals 1 to 10. Okay, and this whole thing divided by 1 by 10, basically divided by 10. Okay, because it's the expected value of xy, right? I mean, that's what you're interested in. Is this fine? This is something that you can easily do, right? I mean, k, what is the sum of squares of 10 numbers. Okay, so you can actually just use that, take 80 out, and then that's it. Okay, that's going to give you expected value of xy. You already know expected value of x and expected value of y, so if you just put it here and put these numbers there, you'll get the covariance. Is that clear? And it will be positive. The reason is because higher the pocket money, higher the spending. Is that clear? Okay, so we can actually think about this very interesting formula, okay, for finding covariances of lots of random variables. A random variable involving sums of lots of random variables. You can actually use this formula for that. Okay, so let me first tell you how to actually derive this formula. Okay, so first let us see what is the covariance between x and x. Well, we already know that's variance of x. Okay, now if I'll ask you what is the covariance between a and x, okay, so that means some constant a and some random variable x. What is the covariance? Obviously, if you just look at this formula, if a is a constant, a minus a will be 0, so this is 0. Okay, so if any of them is constant, the covariance will be 0. Okay, what about the covariance between x plus y and w? Okay, what can you say about that? Okay, so if you just use this formula, okay, the formula above, you're going to get this expected value of x plus y minus ex minus ey, right, into w minus ew, right? Now you can actually break it. Okay, x minus ex plus y minus ey, and then just use the distributive property. Okay, and you'll get this x minus ex into w minus ew, okay, plus y minus ey into w minus ew, right? I can write it like this, yes or no? Okay, and then you can use linearity of expectation. So expectation of this plus expectation of this is exactly this term. And what is expectation of this? Expectation of this is covariance between x and w. And what is the expectation of this? It is covariance between y and w. Okay, so basically covariance of x plus y and w is covariance of xw plus covariance of yw. Is that clear? Okay, another thing is that covariance of a times x into and y is actually, if you just apply the formula, ax a will come out of this, a will also come out of this, and then a will come out of this. So you will get a times covariance of xy. Is that okay? Okay, so if you just keep going, and try and use all of them. Okay, let me just write one more and then I'll write the formula. Okay, this is actually, if you just apply this principle again and again, you will get this covariance of xw plus covariance of xz, okay, plus covariance of yw, okay, and plus covariance of yz. Okay, fine. Now if you just use them, okay, by the way, another thing is that covariance of xy is equal to covariance of yx. Okay, so it doesn't matter in which order you write them. Okay, now if you apply all these, okay, you'll get this formula. Okay, because if I write covariance of I equals 1 to n summation ai xi, okay, comma j equals 1 to m bj yj, okay, then what you're going to get is summation I equals 1 to n summation j equals 1 to m, okay, ai bj covariance xi yj. Is that okay?
Yes, Professor.
Okay.